Hey, it's Joe at Gray Bench Electronics. Welcome back to the bench. Apologies for the 2 week unannounced break. I do have other hobbies that occupy my weekends sometimes. But I'm back and I wanted to do a fun little video here, just going over a purchase I made. These parts came from a local pedal builder who had a bunch of old parts that they just wanted to get rid of or hand off to someone else who would build stuff. And I bought them off of them. So I've got them all here in the box. They're all labeled in bags because that's sort of how I store stuff. They had them in like plastic organizers, which is fine, but they were kind of hard to read. The labels were a little bit faded. So I moved everything over to the plastic bags here, and they're all labeled. So we're going to go through and have a peek at what I bought. There are some parts in here that are not so pedal related, and then there's some stuff that's definitely a little spicier and a little cooler. So we'll go through that. If this sounds interesting to you, feel free to stick around. All right, so right off the bat, I have a bag here. I think these are just a bunch of ICs. I made a purchase a while ago of a whole bunch of conductive foam. That's the black foam that these sit in. Oh, also, I'm wearing gloves today. Hopefully increase the contrast so you can see the parts a little bit better. I'm just gonna pull these out and we'll have just a quick look. I'll admit that I am not like super familiar with these like kind of older ICs. These are SN74H04Ns, mostly Texas Instruments looks like. On this side, a whole mix of 74L series ICs there of all different pins, 8 pins, 9 pins, looks like 12 pins maybe. A whole bunch of ICs there. They have the AMD logo is what it looks like. Perhaps, I didn't know, but I guess AMD made ICs like this back in the day. And these are marked 723DM, 7913EM, maybe is the day code. 7913, like 13th week is 1979, could be. These are CA3046 from ST Electron, or ST, what is ST? I can't remember what ST is. Is that STM? Like ST Microelectronics? I can't remember. CA3046. These are more of the same, it looks like. These are LM318s, National Semiconductor. These are Texas Instruments RC4558, so these are dual op amps that are used in pedals. Not sure if someone out there knows how to date these 4558s. These are PMI PM148s, and I believe that is a day code 8551, so 51st week of 1985. More of those back there. Again, I'm just running through the part numbers. I don't know what all these do. If I can find data sheets, I'll bring them up, and you should be seeing them on the screen if I found them. NE556, I think these are timers. 555 is a popular timer, so probably that. What else? Got some more ICs here. All right, so these are all in the metal cam packages. These look like 8-pin parts, and they're marked also with the AMD logo. LS3265 7928DP, so it could be 28th week of 1979 again. And these ones are marked LM111. I think those are all the same. LM111. I try to group them together. And these are over here, National Semiconductor LM124. There. Some more metal cans. These are marked 2N6790 RCAs. These are Texas Instruments LM193. I believe this logo is Harris, and they're marked 5170-8, and there's another 8650 day code, could be 50th week of 1986. Whole bunch of those. I believe that's the Harris logo, which I think is like Harris Aviation, something like that. And then these are PMI OP07s. So these are single op amps that are a popular choice for Broca rats. As far as I know, PMI was actually the company that invented the OP07, and then Texas Instruments, I think is the most common manufacturer if you're going to go get an OP07 today. But PMI, I believe, is they actually invented it. And 8636, 36th week of 1986. All right, I believe that's it for the ICs. So now we're just going to go through and have a look at, there's a whole bunch of transistors, so we're going to go through those. These are OC171s. I have a video on my channel, which I'll put a link to it up in the corner right there, to see these style germanium transistors. They have a weird property where they will develop little, extremely thin whiskers made of tin inside the transistor body, and they'll actually short out to the electrodes inside. Like you can see here, this one is a used transistor and has a lead missing. They're normally 4-lead transistors. I don't know if you can see, there's a little nubbin right next to the second from the right transistor leg there, and that is the lead that connects to the shield or the package of the transistor. And one repair is you can cut off that lead, which will sever the connection between the PCB and the shield or the casing, which can at least temporarily alleviate some problems that those tin whiskers can cause. So yeah, that's OC71. As far as I know, most of the transistors that are in this package have this problem, although I believe in that video I looked at some Amperex transistors that do not have that problem. This is one of the big scores from this lot. These are OC74s. It's hard to tell from the markings. OC74, we're expecting them to be Valvo or Mullard or Amperex. I believe these are Amperex. Usually the Mullard ones will say Mullard on them. These are essentially the same as the black glass package. They're just covered in a metal shield, which helps with RF interference. But they have the same glass inside, same pinout, all that. OC74s. And there's about, I don't know, 15 or 16. I did do some, and I found, if I recall correctly, for tested specs, let me see. Yeah, OC74s, here's the specs that I tested for these, and they looked great. Leakage was about where I normally see these, in the like 0.2-ish area, with good gains left over. There was one that I have marked off that's leaky. That was this one right here. But the other ones look pretty good, so these will be a prime choice for tone benders, especially Mark I tone benders that need a leaky transistor, something like this one here. Oh yeah, and also on top of the transistors, I'm not sure if anybody knows what this means. On top of these OC74s, they're marked with a letter. Anytime I see something like this, I'm assuming it's like gain bucket sorting that was done by a distributor or perhaps a manufacturer. But you can see here, they're marked on top. Hopefully we can focus. Marked on top of the transistors with different letters. And I marked down those letters just to see if there's any consistency. And it doesn't seem like there's a case, so I'm not sure exactly what they were marking with that. But yeah, if anybody knows, let me know. All right, moving along, we have, these are OPI 1542 in the little TO18 package, 4 leads with gold leads. And I don't recognize the manufacturer mark. Looks kind of like, it looks like an arrow in a circle, something like that. Here's some OC42s. These are marked Mullard. I should mention OC74s, OC42s here. These are both PMP germaniums. These would be white dot OC42s. You can see there they are marked Mullard. With the manufacturing code, looks like ELO maybe. No marks on these or letters, just the white dot indicating the collector. And there's about 5, 10, 12, 13, 14 of those or so. Here's some more OC170s. Same story with these and the OC71s. They developed the tin whiskers inside. Mix of new and used transistors there. Here's some used AC20s, or ACY20s, excuse me. These are all used. I didn't test them. I've had a good number of these kind of like later 60s germanium transistors, TO5 transistors, and most of these are made by ASM, which is Associated Semiconductor Manufacturer, something like that, which was a collaboration between Mullard and 2 other companies that I can't remember. I'm going to put a link in the description for a couple websites to help me sort of decode germanium transistors, and you can check those out. They give you information on different manufacturers, especially UK and European manufacturers. But I believe these codes are ASM. And as you can see, this is a mix of all different manufacturers from all over the place. In here we have a whole bunch of different parts. These are 4062s, 4061s, 4059s, sort of all in that range. A whole bunch of used 4062s, and then I'm assuming because in the market the 4061s and 4059s are both new. Looks like it here. I don't see any manufacturer marks. Oh, there's a TI one in there, and then there's some that look a little different. These ones look like Texas Instruments. So just TO92 packages, probably just BJTs, but all right, these are National Semiconductor MD7000. These are marked NPN silicon, which means they are BJTs, but judging by the package and the number of leads, I'm assuming that these are dual transistor packages, so you'll have 2 transistors per package. And when you have them like this, inside, they're actually made on the same substrates, so they should have very close specs, and they'll also respond the same to temperature changes and different conditions inside the circuit because they're part of the same package. So that's MD7000, National Semiconductor. Some more BJTs, NPN SIs. These are a little bit higher wattage package, you can see there. They have exposed metal in the back for heat sinking. Probably a couple watts. Here's some used AC Y19s. Again, these look like ASM transistors. Here are some unijunction transistors, also used. These are made by General Electric, 2N1671s, TO5 package. Unijunctions are their own type of transistor. Here are 2N2221, so you may know the 2N2222. These are the lower gain brother, 2221, NPN silicon still. And these look to be a mix of Texas Instruments and Fairchild. BSS71, Motorola, these are all used. These are marked NPN-SI, so they're these are going to be a BJT transistor, NPN. BSS71, I don't know. Oh, okay, so these are made by SGS and these are made by Motorola. Here we have some new 2N5416 PMP silicon Motorola TO5 package. This is another big score. The General Electric 2N1305. These are PMP germaniums. The General Electric in these series and the Texas Instruments both tend to be really nice gain and really low leakage. So these are great choices for any transistor or any germanium fuzz pedal that doesn't need leakage, because these tend to be pretty clean on the leakage. I think I tested these. Oh, here's the OC42s that we looked at before, the Mullards. Again, really good, nice gains in there, really low leakage, which was nice to see. I think the person I bought these from had their collection going, you know, several years ago before stuff really got picked through, which was nice for me. All right, 1305s. Yeah, here's the germanium or the General Electric 1305s. Really good gains. Perfect, like fuzz face territory, really low leakage. As you can see, this is in microamps of leakage, so 0.039 milliamps. Oh, 0.039 milliamps, 0.049. And these are your true gains, because this is measured with the DCA 75. A little bit higher than you would find as far as gain versus like your bare bones test that Small Bear does, or RG Keen's test, because those both test at around 1 milliamp. The DCA 75 test is 75. If you're interested in all that, I have a video on testing germanium that I go over that. But yeah, still good gains. Definitely good choices for a fuzz face or any, like I said, any germanium fuzz that doesn't need leakage. ACY 17s. These are marked UM on top. There are codes that can be decoded for these. I don't remember, but again, the font to me, it looks like ASM. BC109s, these are all used. Manufacturer looks like ITT, which is a electronics distributor, I believe, in Massachusetts. Just looking to see if I see any other. Oh, I see some National Semiconductors in there too. So these are all BC109s, a different make, used transistors. These are just a couple ACY. So germanium, any of the AC blank for the European are germanium transistors. And there's just a couple just used ones there. 2N3702s from Texas Instruments, PMP silicons used. 2N3073, these are PMP silicon BJTs. A whole bunch of those with the super long leads. They're like TO18s, but really long leads. And these are all 3 lead packages made by Fairchild, that's F. And then there are also some, these non-semiconductors. These are like precision 0.5% tolerance resistors that are in like a radial package here. Sort of like a box film capacitor, but they're actually resistors. And they're made by Vishay Welwyn, W-E-L-W-Y-N. Let's grab some more. I hope this isn't boring for y'all. I find this really interesting. Just to see these old parts and have them around is just really fun and interesting to me. We got a couple more ICs here. I know there's some cool ICs. Oh yeah, these are the ones. These are super cool. Check these out. If I can get the bag open. Oh my God. I almost ripped the bag out of frustration. A little more perseverance. Here we go. So these are, the manufacturer mark looks like MMI. And the part number is a super long one. I'll just let you read it there. So these, I looked these up. I'll put a data sheet up there because I think I did find a data sheet. It's definitely a computer chip of some variety, but check these out. You can see here, I believe these are memory, like RAM, effectively. First off, super cool logo with the tree and the circle. But the window here, what you can actually do is you can hit this with a UV light and it'll actually like flash the memory, clear it out. So they actually have a window down into the actual circuit itself. And if you look closely, you might not be able to see it on the camera. I don't know if this will, no, it blows it out. You can actually see down to the silicon wafer. And it's super cool. Yeah. Really cool. If these are date codes, this is 58th, well, can't be date code then, never mind. I was going to say 58th week of 1983, but last time I checked, years only have 52 weeks. So not a date code. But yeah, super cool. These are really interesting. Completely useless for guitar pedals as far as I know, but still really cool. All right, back to business. These are 2N2484 NPN silicon BJT transistors made by Fairchild. These appear to all be new. Different, some just standard like tin or silvered legs, some of them gold. These are TIC126 SCR silicon controlled rectifiers in a higher wattage package like that. A couple of those. 2N2907As. These are PMP silicon transistors. These are used in a pedal. I believe I want to say the Devi Ever Hyperion uses a 2N2907A, I think. Motorola used. Whole bunch of used 2S series PMP silicon transistors. These can trip you up. When I was getting started, I looked at these and I was like, oh, these are definitely germanium because of the package, but they're not. In fact, these are Texas Instruments made, and they're in a sort of TO1-ish looking package, but they are in fact silicon transistors. For this series, you have 2S like this, and then some numbers, and you also have 2G. The S is silicon, the G is germanium. Here's some more of those precision resistors, 29 ohms and 0.5% tolerance. And judging by the size, it looks like a decent wattage handling as well. We've got some Panasonic NPN BJTs, C945, so that'd be 2SC945. Sometimes they take off the 2S because it's a given, and these are Panasonic, which back then it might have been Matsushita Panasonic because they merged companies. BC107s, NPN silicon transistors, these are all used. And the manufacturer, there's an SGS in there. Looks like maybe all SGS. Maybe, probably some there's some Motorola's in there as well, unsurprisingly. These are Teledyne T3416 NPN silicons. Teledyne has a really cool logo, which hopefully I can show. It's kind of hard to see. It's like half of a sort of geometric flower shape. I don't know if you can see it there. It's like half of a little flower. Really cool logo. These are TIP47 NPN BJTs. higher wattage. These all look used. Motorola. 2N3921 dual JFETs. So there's actually 6 leads coming out of these little TO18 size packages. And those are N-channel JFETs. 5210s, NPN BJTs in the TO92 package. Actually, these are not TO92 package. These are a smaller, slightly smaller, but still like black plastic epoxy package. Same lead spacing approximately. Got a couple of ICs it looks like I forgot to put into conductive foam. I will do that promptly. These are MC1558s from Texas Instruments, dual op amps. I'm going to set those aside to put them in foam. These are 1S or LS 610s, and these are marked SCR. I must have got these out of a bag or something that was marked that, because they're not marked on the package itself. So if you're ever getting stuff like this and you see transistors that are not marked, hold on to the original marking, because chances are people didn't just throw a random number on there. It's probably correct. And if you lose that, then you will never know. You can do tests to find out what its function is, but as far as like if you want to look up like maximum ratings and whatnot, having the part number is good. 2N2369, these are SGS NPN BJTs. Silicon, of course, TO18 package. 2N4093 NJFETs, N-channel JFETs, TO18s, and they look like Motorola's. Yep, Motorola. BCY71, so ACY, we said was germanium transistors. BCY are the silicon. 2N3866s, NPN BJTs in the TO5 package. Manufacturer is unknown. Not marked any way I can tell. 2N1090s from RCA. These are NPN germaniums. I don't think I tested these, so why don't we pull out the DCA75 and just throw a couple in there and see what happens. Finding good high gain, low leakage NPN transistor or germanium transistors is difficult. So if these test well, that's a good thing. I'm going to try and open up the leads here. These are fairly dirty, kind of corroded. Also with germanium, of course, you have to be careful not to touch the transistor too long, or at least let it cool off before you test it, because the heat from your fingers can throw off your readings. So I'm sort of gonna just set the leads here, give them a second to cool off, and then I'm just gonna manipulate them with pliers here. Grab on. So these are 2N1090s from RCA, which are NPN germanium. NPN germanium, 71 HFE, not terrible. And leakage of 26 microamps, so that's great. I always run 2 tests just to see if there's any hint of stability, which is good. Okay, 71 again, so that's good for like a Q1 of a fuzz face. And 31 microamps of leakage, so that's great. Getting under 100 microamps of leakage with any appreciable amount of gain out of an NPN germanium is lucky. It's good. Let's try another one. I'm not going to test all of these. This video is getting long already. There's another one. We'll do this. We'll do one more. 57 gain, so not quite as high. Leakage 23 microamps. Okay, so the leakage is staying down, but so is the gain. Not totally dissimilar from like the Soviet transistors that you can find on eBay. 57, so that's stable. Leakage 25 microamps. So not super great on the gain, but they're low leakage, which is good. And we'll test one more. .56 gain and 60 microamps. So low to medium gain and low leakage for these 2N1090 NPN germaniums. I personally like the gains in my fuzz face a little lower. They clean up a little bit better. The fuzz is more manageable, I guess you could say. If you like using fuzz faces to get an overdrive sound, using lower gain transistors is viable. If you want that full raunchy lead sound, then maybe not so much. Use some louder sounds or even silicon transistors. But yeah, so there you go. RCA 1090s, NPN germaniums. Moving along, we got some ACY 21s, more used ones. Looking at these again, all these UK or European made ones, they all kind of look the same. These are marked YVC, ACY 21s, again, probably ASM. 2N2905s or also CV7672s. CV is the military designation for UK transistors. Stands for common valve, but it just means it passed certain military specifications. 7672 is the equivalent to 2N2905, but with the military passage marks. And you'll often find that they have little markings on here to show they've been proofed for military use. So you can see there's a little, so you can see hopefully there's a little up arrow. That's the sign of it's been approved for military usage. There's a specific designation what that actually means, but it's essentially that's the gist. A couple more ICs that I need to put in conductive foam. These are 741s, LM741s or U741s, single op amp used in the MXR, what it was, MXR distortion, I believe, is a 741. And these, as far as manufacturer, are, well, these are Teledyne. At least one is Teledyne. I can't see the other ones, but there is a Teledyne one in there with that cool logo. I'll put that in foam. Some more silicon control rectifiers, 2N1627. Manufacturer is not marked. BC109s from SGS, gold leads and not used. So these are great for buzz face, really anything you need a reasonably high gain NPN BJT. Pull some more out. They keep going. There's a lot of stuff in this lot. BSS62 from Motorola, PMP silicon BJTs. And these are, yeah, Motorola. Some BF series, BF181s, NPN silicon BJTs. Manufacturer is, I don't know if I know that one. I don't recognize that logo at all. It's kind of a cool logo though. We'll see if I can bring this up for viewage, see if someone out there knows it. That's a pretty cool looking logo. TV antennas coming out, maybe like a CSP, something like that. If anyone knows that logo, let me know. And BF181s. The other numbers there are 7332, so that could be a date code. 32nd week, 1973. Here's some more Mullards. These are OC202s. Now the OC2XX series are silicon transistors. They look just like their germanium counterparts, so be careful, don't get duped. But these are Mullard marked OC202s, Great Britain. These, in my testing, very low gain, very low leakage because they're silicon, but very low gain, usually in the like 20, maybe up to 40 HFE range. I have experimented with these with, oh God, what is it called? Like complementary pairs, like Zicli pairs or Darlington pairs. And they kind of work, but I haven't played with them that much. It didn't really do anything special for me. So I think I had a bunch of these and I sold them off to somebody. And now I have a bunch more. So round and round we go, I guess. But yeah, these are PMP silicon transistors. They look just like germanium. So don't get burned if you're buying some. Just make sure to check the part numbers. OC202s are silicon. BFX40 SGS, PMP BJTs. Not all SGS. Some of them are Motorola. I can see that. And yeah, BJTs. BCY39s, again, PMP silicons, TO5 package. Manufacturer is, I don't know. But again, I'll reiterate, a lot of the UK transistors from this later period are ASM. They really took over the market, at least if I'm judging by what I've bought so far. Fairchild, 2N3300 NPN BJTs. 2N3819 JFETs. I think I actually have some of these in like, no, not out here. I believe I have some of these in like the original kind of cardboard blister packs, but these are just loose. They're N-channel JFETs. I believe these are one of the earlier JFETs actually. 2N2297 NPN BJTs, SGS with the gold leads. We got some ZTX 600, which usually when you have like a weird or uncommon prefix, you can assume that's just 2N600. I don't know if that's the case for this because that low number could be germanium, and these are definitely not germanium. As far as I know, there are absolutely no transistors made in a plastic package that are germanium. But these are ZTX 600, and they are NPN BJTs. Manufacturer appears to not be marked, but ZTX might refer to the manufacturer. BC179s, PMP silicon BJT. No manufacturer marks on those. There is a P though, which might be Philips. BC183s from Texas Instruments. These are used, I definitely think these are used for something. I feel like I've seen these sell for relatively high amounts. It might be BC183Ls are used in maybe silicon fuzz faces. I might be misremembering. These are Texas Instruments. They are used, and they look like that. SGS, it's a house code, but apparently equivalent to 2N2369 NPN BJTs. A couple used ones, mostly new. 2N3209s PMP BJTs. These are used from ITT. These are 2N1890 NPN BJTs from Texas Instruments, TO5 package. These are marked BUX86 NPN BJTs, and judging by the package, a little bit higher power rating on these. Here's a little more of those precision resistors, 8.66K at 0.5% tolerance. These are BF196 and 197. Used, it looks like. Maybe some new ones down there. Manufacturer does not look marked, at least not clearly. Here's some ACY17, so these are PMP germs. They're all used. Manufacturer is not marked. Actually, I see an NKT there, a new market. I don't see for these other ones what they are. Here's some 5415s, PMP BJTs. These are all used. 2219s, NPN silicon BJT. These are a popular choice for pedal builders because they are keep the gain relatively low. You can find these between like 100 and 200 HFE. These are Motorola's. Coming to the end here. For the 4 of you who have stuck around, I appreciate you. So these are kind of interesting ones. They showed up in these tinfoil packages, so they're probably very static sensitive, so I'm going to leave them in the package like that. They're marked to BFT65 NPN silicon BJTs. Hopefully the last of those precision resistors, 8.25K at 0.5% tolerance. ASY29s, these are new NPN germaniums. And a code here, these don't look like, so these look a little bit different than the other UK germaniums. There's another company from UK that I can't remember the manufacturer. I believe they're the other company that merged with Mullard for ASM, but I can't remember. But they are NPN germs, ASY29s. 2218s, Fairchild, NPN BJTs. 4858s and channel JFETs. See these in pedal designs pop up every once in a while. Looks like mostly used. Here's some gold-plated 2222s if you want to get a little bling going on in your typical like BJT build. Got some Texas Instruments fully gold-plated 2222s. 2369 NPN silicon BJTs, SGS. I know we've seen these before, so I might have to consolidate, but yeah, lots of gold in there. 3053s, NPN BJTs, very common part number. These are all used. BC183s, these are also Texas Instruments, BC183s. And then last but not least, I set these aside. because I just thought these were like maybe the coolest thing in this lot. These are gold-plated National Semiconductor LM308s. I didn't even know these existed, and I've looked around at like different rat op amps. These are what is that? 14-pin LM308s, gold-plated National Semiconductor. How cool is that? You wouldn't be able to use these in any like common rat PCBs because they're not 8-pin dips. You need at least some kind of adapter or to design a PCB around them. But man, that's cool. And the gold would obviously, you know, make it sound better. So, all right, so that is it. That is all the components I bought out of that lot. Lots of stuff here. Most of it relatively unuseful for guitar pedals, but yeah, I hope you found this interesting. I would be slightly surprised if you found it as interesting as I do, but maybe I'm wrong. Maybe you guys love this stuff, and I'd love to hear about it if you do, because I do buy these lots every once in a while and go through them, and if you want to see more of this, just let me know. If you enjoyed the video, I appreciate you hitting the like button and subscribing. I'm Joe from Gearmannium Electronics. Thank you for watching.